Moving on to example 2 of finding domains of piecewise defined functions. Here, we're looking at a function f of x defined to be 1 over x minus 1 whenever x is greater than or equal to minus 2. And we're looking at whenever x is less than minus 3, f of x is going to be 3x squared plus 2x. All right, so in order to find the domain of this guy, I'm going to use the shade and erase method. So first thing we're going to do is look at the intervals on the right-hand side of this piecewise defined function here. Always start at the top here. So we're looking at x is greater than or equal to minus 2. Since we have equality, I'm going to put a square bracket on minus 2. And then since x can be greater than or equal to minus 2, greater than is to the right, so I'm going to shade this way. Okay? So x can possibly live in here. F of x might be defined for all possible values in this interval. It might not be. So we'll have to come back and then check each of these functions case by case. So then that handles this guy. We're going to handle this guy next. So we have x less than minus 3. So we put a round bracket because it's strictly less than minus 3. And then x is less than it, so I can shade this way forever. So there's a gap between minus 3 and minus 2. All right? So we'll never be able to plug in minus 3 or any value in between minus 3 and minus 2. All right, so now that I've shaded my regions with these two criteria, let's take a look at this function and this shaded region here. Is there a possibility that I might get division by 0? Turns out the answer is yes, because if I plug in 1 here into the denominator, I'll have 1 over 1 minus 1, which is 1 over 0. And that doesn't exist. That's not defined. So at 1, x is equal to 1, which is right here on my number line, I'm going to erase that point there. And I'm going to put a round circle right at that point. It's going to be open. All right? So I can plug in everything up to 1, not including 1, and everything greater than 1. All that is still okay. So I just erased the things that cause problems. Okay? And I put a round circle there. And that's the only thing that causes problems. That's the only place we're going to get division by 0. Okay, so now we're done with this guy. Let's handle this one. This is a polynomial. So we have 3x squared plus 2x. There's no chance for division by 0 here because there's no fraction, and there's also no radicals. So this is going to be defined everywhere. And it's certainly going to be defined on this region, which is when x is less than, strictly less than, minus 3. So we're okay with this. We don't have to erase anything on this side. So the domain of our function is going to be starting from left to right, minus infinity, scanning up to minus 3, not including it because I have a round bracket. Then I pick up, using a union symbol, at minus 2 inclusive because I have a square bracket there. Then I can go all the way up to 1, not including 1. So I put a round bracket. But then I pick up just after 1, use a round bracket again, and I can go to infinity from there. So at which point, this is our domain of this piecewise defined function. Yes, it has 3 parts and 2 different union symbols, but that's okay. All this means is that I can plug in any x value into this function as long as it lives in one of these guys, in one of these intervals here. So that's the domain. In which case, we are done with this example, and in example 3, we'll move on to a slightly harder case that involves radicals and possible division by 0. Hope to see you in that video. If you found this video helpful, please like and subscribe.